branch and the topic is electron devices. In this we are discussing about one more questions. The second one more question in the series is the diodes and capacitors shown in the circuit are ideal. The voltage V of t across the diode D1 is A cos omega t minus 1 sin omega t, C 1 minus cos omega t, D 1 minus sin omega t. Look at the circuit. The input signal is cos omega t and there are two diodes which are acting as ideal diodes and two capacitors are connected as shown. V of t is nothing but voltage across diode 1. So for diode 1, P side is nothing but positive terminal and N side is nothing but negative terminal for the voltage V of t. We need to calculate that voltage for this one. The right answer for this question is A cos omega t minus 1. We'll see the explanation now. This is a given circuit and cos omega t is the input signal which is sinusoidal signal which starts from at t is equal to 0 with maximum value as 1 volt. Later it is going to be sinusoidally decreases and increases periodically. So cos omega t is consisting of positive and negative cycles which are going to be applying periodically one after the other. While analyzing this circuit, we start with at t is equal to 0, cos omega t is maximum value has plus 1. So plus 1 is going to be applying towards diode 1 and diode 2. But positive 1 plus 1 is applied to P side of diode 1 which makes diode 1 forward bias. The same plus 1 volt which is applying towards diode 2 which makes the diode becomes reverse bias. So at t is equal to 0, cos omega t has plus 1 volt that makes diode 1 forward bias and diode 2 reverse bias. Before that one, assume that one capacitors are uncharged initially. So whenever diode 1 is forward bias, since it is ideal, it acts as short circuit. Whenever it is act as short circuit, the equivalent circuit is like this. By that time, the effect of D2 and C2 is going to be overwritten by diode 1. Since diode 1 is acting as short circuit, the current supplied by cos omega ct is entirely going into this diode 1. By that time, capacitor 1 starts charging. Always capacitor starts with time constant. Time constant is nothing but product of R and C values. If the time constant is smaller, at that time it charges rapidly. If the time constant is longer, it charges slowly. So now we will see what is the time constant for this circuit when the diode is forward bias. Time constant is denoted with tau and the units are going to be seconds. Tau is equal to product of R into C. R is effective resistance in the path and C is effective capacitance in the path. That is, that path is nothing but in that circuit where the current is flowing. So during this current flow path, which includes cos omega t, C1 and diode 1. Cos omega t doesn't have any resistance, C1 is ideal, D1 is ideal. So in this during total current path, it doesn't find any resistance. So tau is equal to R into C, R is 0. That makes tau is equal to 0. Tau is equal to 0 means capacitor starts instantaneously. Whenever you apply any voltage, that will be taken by the capacitor by that time itself. So capacitor 1 starts charging instantaneously. So at t is equal to 0, cos omega t input signal is giving plus 1 volt that will be taken by the capacitor 1 at that instant itself. So at t is equal to 0, the capacitor 1 has reached plus 1 volt. Whenever capacitor 1 takes plus 1 volt in this direction, as indicated plus minus, since the current is flowing, first you will get positive terminal, next that negative terminal. Current always flows from positive to negative terminal. So that makes diode 2 to become reverse bias, because the effective voltage across P side of diode 1 is always negative. Observe this one. Capacitor voltage is constant at plus 1 volt, that is minus 1 volt in this case, and cos omega ct values are going to be in between plus 1 and minus 1. The values are in between. So if you take KVL over this point, always this potential V of t is cos omega t minus 1, cos omega t minus 1. So this minus 1 will dominate for all the values of cos omega t. Even though the maximum is plus 1, the voltage across V of t is 0. It is not positive. So this voltage, effective voltage, may be either at 0 or may be either at negative voltage. That makes diode 1 reverse bias, diode 2 forward bias. This is the circuit. Effective voltage across this point, making the diode 1 reverse bias, diode 2 forward bias. So by that time diode 2 is forward bias, act as short circuit, and now that makes the capacitor C2 to charge. Since the diode is going to be in this direction, always current flows in the diode from P to N side whenever it is forward bias. So the voltage across C2 is going to be indicated as plus minus in this way. Now we need to calculate voltage across diode 1, that is V of t. So simply apply KVL across this loop. Apply KVL across this loop. That is nothing but cos omega t minus 1 minus Vd1 is equal to 0, this loop. So Vd1 is equal to cos omega t minus 1. Vd1 is voltage across diode 1, which is nothing but required V of t. So V of t is cos omega t minus 1. This is the answer. So for the given question, the right answer is cos omega t minus 1. Thank you.